Hello, everyone. I'm Olympia. Thank you for being here with me in this wonderful place called Lights Out Library, and I have a great story to tell you. Tonight, we're going to explore a mysterious continent, one that we all visit regularly, the world of sleep and dreams. I will tell you about what happens when we sleep, what occurs in our brains, the rest of our bodies, and also in our minds. We will explore the concept of consciousness and intermediary states, like lucid dreaming or sleepwalking. I will discuss dreams from various perspectives, including neurobiology, psychiatry, psychology, and culture. As part of the human experience, dreams have acquired different meanings throughout history and in the arts. I will tell you about how humanity has approached sleep and dreams. The scientific study of sleep and its biology is still a recent endeavor. Prior to that, there was a wealth of hypotheses, beliefs, and myths surrounding sleep. We have a lot of things to explore tonight, and it's even better because this story is also intended to help you fall asleep, if you wish. As always, you do not need to watch the video to follow along. If you wish to, you may close your eyes and forget about any worries as we embark on this adventure together. Also, we created a Patreon page for those of you who wish and can support this project and get more of it. If you join, you will get various new things like the possibility to listen to all episodes with or without background sounds, regular bonus episodes. We already have 3 episodes only available to our Patreons, with the latest one being The Life of Frida Kahlo. You will be able to download all these audios, and you will also have your say on the choices of topics, advance releases, and updates on upcoming episodes. We hope to see you there soon so that we may continue developing Lights Out Library, which we enjoy so much. You will find links in the description box and the first comment pinned under the video. If you fall asleep and wish to resume the video later or jump directly to a particular part of the story, timestamps are also listed in the description and pinned in the first comment, as well as links to different streaming options like Spotify, Apple Podcasts, and Amazon Music, which may be better suited for you. But before we begin, let's assume a comfortable position, shall we? Take a long, deep, relaxing breath, and when you exhale, release the tension in your shoulders, your neck, release the tension in your facial muscles too, and allow the sound of my voice to guide you through this journey. Okay, so now let's start. Right now, you may not be asleep as you are listening to this, but you are somewhere in a cycle that inevitably will evolve into a sleep phase later. Maybe in minutes, maybe in several hours. Even though this cycle is disrupted for many of us, or even though you often have trouble sleeping, many people have a hard time finding sleep during the hours that should be dedicated to it. It may be occasional due to worries or external stimuli that keep you alert, or it can be chronic, psychological, or because of physiological reasons. But however hard it is, ultimately, you will find sleep, and you will get rest from it sooner or later, without thinking about it, you will drift into a state of drowsiness or somnolence, and you will transition from wakefulness into sleep. Sleep onset happens when some of the cells in our brains, some of the neurons that are silent when we're awake, become active. They release specific neurotransmitters, which are chemical compounds, chemical messengers that transmit messages between cells of our nervous system and to other cells of our body. More than 200 different neurotransmitters have been identified. There may be more. They all have a role to play in the process that keep us alive, give us control over our bodies, and also manage our transitions from awake to asleep. Despite the alteration of our consciousness when we sleep, our bodies keep working. We breathe, our hearts beat, and a lot of things happen inside that we are going to talk about later. First, let's take a look at the various states or the various phases we experience when we fall asleep, whether it's a nap or a night's sleep. We may feel like a switch has been flipped, and when we wake up, time has passed like in an instant, but in fact, a lot has happened. First, after sleep onset, we fall into a state called quiescent sleep or non-rapid eye movement sleep. Because we will see later that after quiescent sleep comes another phase called rapid eye movement or REM sleep. When our eyes move quickly under our lids, it is possible to track what happens in the brain with electroencephalography. Electrodes placed on someone's head to record electrical activity in the brain. This method obviously doesn't give a detailed understanding or insight into what happens in the brain. It is just about measuring signals produced by its activity. Electroencephalography, or EEG, very clearly shows the different stages through which the sleeper goes. Electrical activity gives different waves and different wavelengths. In the first stage of quiescent sleep, which is a transition, a kind of relaxed wakefulness, waves measured by an EEG change, reflecting the passage from one state of consciousness to another. However, it is still easy to get out of this transition phase if there is an external stimulus, like noise or something even without a stimulus. Maybe you have experienced a sudden contraction of the muscles in a limb that makes you jump and suddenly awaken for a moment. This is called a hypnic jerk, and it is quite common and totally involuntary. It takes you out of this first phase, but generally it is followed by a quick return to sleep onset. The first stage of quiescent sleep is quite short, a few minutes at most, because it evolves towards the second phase of light sleep. We know it is the second phase because the waves on the EEG change again. It now tends to show short characteristic bursts of neural activity. These are called sleep spindles, and they alternate with long waves called K complexes. At this point, the meaning of these signals is largely unknown. The origins within the brain have been found, but their function is still a mystery. This illustrates how much we still do not know about the human brain. A lot of progress has been made in the past few decades, thanks to methods like EEG and medical imaging. The brain has been mapped out and examined from multiple angles. Its biochemistry is better understood, but many questions remain about why it works the way it does and the relationship between signals that are measured in the brain and our states of consciousness or our control over our bodies. Stage 2 of quiescent sleep is sometimes called light sleep because the sleeper can easily be awakened. There is still a degree of alertness in case something happens around them. This alertness and the EEG signals associated with stage 2 are going to change again as the sleeper enters stage 3 or deep sleep. It is also called slow wave sleep because the EEG activity shows synchronized and slow waves of relatively high amplitude. Certain zones of the brain that are active when we are awake and keep working during the previous stages can finally begin to rest. At least this is what their electrical activity suggests. There have been studies of sleep deprivation with humans that indicate that the primary function of deep sleep may be to allow the brain to recover from its steady activities and also to consolidate memory. Memory is an entirely different topic that maybe I will tell you about in another story. But as you probably know, we forget a lot of what we do. There are many memories that may be hard to access when we want to, but they are there and eventually we will remember them. These have actually been stored. But there are also many potential memories that our brains decide to get rid of because they are considered not memorable or important, and these are erased forever. These include things that you even did yesterday or 2 days ago, and you may be under the impression that you can actually remember your day quite precisely. Maybe you can, but there are still plenty of details that have already gone. And more will go after several more nights. And it probably happens for a reason. As living beings, we need to organize and somehow rank our memories by importance or by category, shedding the ones that are not particularly relevant may actually be useful for us to function. This process is not totally independent of our will. If you decide to remember a detail and make a conscious effort to remember it, you are much likely to remember it. The vast majority of those memories that get erased are routine tasks. For example, you probably made tea or coffee or brushed your teeth thousands of times in your life. If you try, you can certainly remember several occurrences of these, but certainly not all of them because they are gone. Deep sleep also affects other functions, including the higher secretion of growth hormone. Growth hormones play an important role for children and teenagers as they stimulate human body development. But we will produce them all along our lives. It accelerates cell production and cell regeneration. The production of growth hormones reaches its peak during stage 3, during deep sleep. So as you can see, there are several aspects of deep sleep associated with the restoration of our bodies and, beyond that, the structure or the functioning of our conscious minds for when we are awake. Stage 3 is considered the deepest stage of sleep, based on how far it is from our awake state in terms of sensitivity to external stimuli. Historically, a distinction was made between Phase 3 and Phase 4, with Phase 4 being deep sleep and Phase 3 the transition to it. However, nowadays they are generally merged into a single phase because the EEG measurements are very similar. But this is not the end of the sleep cycle yet. After the various stages of quiescent sleep or non-rapid eye movement sleep, the sleeper is now going to enter a very different phase, rapid eye movement, REM sleep, also known as paradoxical sleep. The whole sequence with the stages of quiescent sleep and paradoxical sleep does not encompass an entire night's sleep. It varies, but on average, the whole cycle, 3 stages of quiescent sleep and paradoxical sleep, lasts around 90 minutes. So, in an entire night's sleep, there are 3 to 6 of these cycles. Even though we often don't remember it, it is common to wake up briefly between the cycles. Maybe you are used to waking up, changing positions, and going back to sleep during the night. Chances are these awakenings happen when you exit paradoxical sleep and restart another sleep cycle when you go back to sleep. You may also have noticed that these moments when you briefly wake up are moments when you realize you just had a dream. This is not surprising because during paradoxical sleep, when our eyes are moving rapidly out of our control, we don't realize it. This is the moment when dreams are the most vivid and apparent. I will tell you about dreams later. For now, let's take a look at what paradoxical sleep is. As I mentioned before, this phase is also called rapid eye movement or REM sleep because it was its most obvious characteristic when it was discovered in the 1950s. But its effects extend to the rest of the body and the brain. Once again, the abundance or absence of certain neurotransmitters change during this phase. One characteristic of paradoxical sleep is the abundance in the brain of acetylcholine, one of these neurotransmitters. The transition to REM brings marked physical changes. The body, from the beginning of the sleep cycle, maintains very steady conditions of temperature, breathing, and blood circulation. All of these are stable. In REM, large fluctuations in these functions appear. The rhythm of breathing may vary. The heart may accelerate and body temperature may rise or decrease to near waking levels. REM sleep restores some of the functions of the awakened state, but we are still sleeping and unable to notice it. On the other hand, muscle tone in most of the body's muscles is reduced, a condition known as muscle atonia, or REM sleep muscle paralysis, in which a neural short circuit eliminates strength in all muscles except for necessary functions like the heart and the lungs. This means that the sleeper can no longer move. Motor neurons are completely inhibited. It is a form of paralysis, but one that has its advantages and usefulness. Because vivid dreams accompany this phase, and without this paralysis, sleepers could move a lot, unaware that they are in a dream. It has also been observed that the use of energy in the brain, measured by the metabolism of oxygen and glucose, rises significantly during REM sleep. It becomes similar or even exceeds the energy consumed in waking. This is why REM sleep is called paradoxical sleep. It is paradoxical in the sense that the body and the brain are on energy consumption levels similar to wakefulness, despite the body's paralysis. As soon as we wake up, the inhibition of motor neurons ends and we retake control. But there is a state called sleep paralysis that happens when people fall asleep or when they wake up, which the person is aware but unable to speak or move. These episodes may come with hallucinations of being touched or hearing something and induce a lot of anxiety because the hallucinations feel perfectly real. It is not uncommon. It is estimated that up to 50% of people may experience sleep paralysis at least once in their lifetime, and about 5% of people have regular episodes. It is believed that the mechanism involves a dysfunction in paradoxical sleep. Somehow, the return to normal motor functions is delayed, creating a sensation of being trapped inside one's body. Skeptics believe this could explain some stories of paranormal events, like alien abductions. People would be absolutely sincere because they were indeed not dreaming, but hallucinating while awake, which is a very different experience. And at the same time, they were paralyzed. Maybe if it happens to you one day, the best thing to do is realize that this is rare, but not uncommon. You are not fully paralyzed. The fact that you are awake and conscious means that your heart is beating, you are breathing, and at most, these episodes can last a couple of minutes, so you are going to be all right. During the night, with several sleeping cycles lasting around 90 minutes, there are several episodes and phases of REM sleep. As the cycles pass, REM sleep phases tend to last longer. When the phases of sleep are measured by EEG, for an average sleeper over a night of 6 to 8 hours, the cycles change. Successive quiescent sleep phases tend to be shorter and less deep, measured by the duration of slow wave sleep. On the other hand, paradoxical sleep lasts longer and is more likely to end in an awakening. So why is there this phase of REM sleep? What is its function, given that the brain and the body don't seem to rest during it? And why do eyes move during this phase? A possible explanation is that the eye movements relate to the sense of vision experienced in a dream. However, this explanation is not fully satisfactory because it has been observed that people who were born blind still move their eyes in REM sleep, even though they typically do not have visual imagery in their dreams. Another hypothesis explaining eye movement is that it is only a side effect of the brain processing memory, but this is not fully explained at this point. Despite the higher energy consumption and activity in the brain and the body during paradoxical sleep, it seems to be biologically necessary. In experiments, people were deprived of REM sleep, and the phases of their sleep were monitored by EEG. They were woken up every time REM sleep began. When the experiment ended and they could sleep without interruption, they had longer REM sleep phases, as if they were catching up. REM sleep deprivation has been associated with a state of irritability and anxiety, with difficulties in staying focused, too. So biologically and psychologically, REM sleep is important, but it is unknown why and how. There are various hypotheses about it. It could be important for the preservation of certain types of memories related to space or emotions. For example, it has been observed in rats that REM sleep tends to last longer following intensive learning sessions, as if they needed to process the acquired knowledge. On the other hand, studies on a few rare individuals that are chronically deprived of REM sleep because of injuries to their brains that didn't let them enter this phase or stay in it showed that their memory was not significantly affected in the long term. Another theory is that REM sleep acts like a neural stimulation. It would create and maintain neural connections in the brain. An element in favor of this idea is that REM sleep prevails the most just after birth and then diminishes as we age. For newborns, it could aid the developing brain to form connections. Yet other theories are connected to evolution. It could be a transformation that happened millions of years ago of a well-known defensive mechanism called the tonic immobility reflex. Various animals can feign death as their last line of defense in front of a predator. Their bodies suddenly become immobilized and stiff, which makes them appear dead. Of course, humans and many other animals with complex nervous systems cannot do that. But there are a number of similarities between their REM sleep and tonic mobility, paralysis, changes in temperature and activity in the same zones of the brain. REM sleep could be an evolution that we inherited from ancient life forms, but that no longer serves as a defense mechanism. Still related to evolution or self-defense, REM sleep could be a process to reactivate animals and humans periodically to scan their environment for possible predators. I mentioned earlier that sleep often ends in a brief awakening before a new sleep cycle begins. This doesn't explain the muscle paralysis, and it seems contradictory if it is to escape a predator. But maybe this paralysis ensures that the animal doesn't move and attract attention involuntarily before it is fully awake. That's possible. But the truth is, we don't exactly know why these REM sleep phases exist and what purpose they serve, if any. However, the most notable aspect of this phase for us is the intensity of dreaming. So let's talk about dreams. Dreams do not only happen during paradoxical sleep. There can be some during the phases of quiescent sleep, but not as many and not as vivid. We are also much more likely to remember REM dreams because we typically wake up briefly after this phase. Dreams are not easy to define. We all know what they are about because they manifest themselves as stories, or at least as a succession of images, ideas, emotions, and sensations that occur in the mind. Without these sensations and images, the dream itself might be a side effect of something else. They are also deeply personal and connected to our lives. We dream of elements we know, or that we seem to create based on things we know. But it is hard to retell a dream as if it was a movie or a story that we just watched. Dreams are also full of emotions, and we seem to be thinking in them. Most of the time, we are not aware that we are dreaming when we dream. It is only when we remember a dream that we put it at a distance and can rethink it as a third person. I said most of the time because there are lucid dreams too, which I will tell you about later. There are different ways of looking at dreams, and they all have interesting observations to bring. They can be approached by neurobiology, What happens physically and measurably when someone is dreaming? They can be approached via psychology and psychiatry too, focusing more on the content of dreams, their context, and possible meaning and function. Or maybe not everything has a meaning, and dreams could be the product of random brain activation that our minds process to give them an apparent logic or significance. There is also a cultural approach to dreams. They are part of the human experience, and since ancient history, they have been attributed a wide range of functions and meanings. When it comes to biology and neurosciences, we have seen that the various phases of sleep are piloted from the brain, and that, depending on the phases, the active regions of the brain and the types of neurotransmitters are very different. So, one of the central questions of sleep research is what part of the brain drives the dream experience. When we are awake, most of the internal imagery in our minds that helps us reason, plan, and strategize for every action is controlled from the front of the brain, a region called the lateral prefrontal cortex. This part of the brain acts like a puppeteer or a processor, assembling objects stored in memory into combinations. But during the most intense dream phase of sleep, in REM sleep, the lateral prefrontal cortex is inactive. It seems this region of the brain is irrelevant to dreams because, for people who have suffered brain damage in this area, dreams do not change at all. It isn't clear how images or sensations appear in one's perception during REM sleep, and from which part of the brain. It could be that other regions of the brain, other than the prefrontal cortex, take over and do the job of trying to elaborate a coherent imagery. Because it is not their primary function, and they are not the usual processors of reasoning and strategizing. They would make different associations that would give dreams their sometimes unreal or illogical aspects. However, dreams are not floating in the mind separate from matter. Dreams can be inhibited physically by blocking a neurotransmitter called dopamine. Conversely, an increase in dopamine stimulates very vivid dreams and nightmares too. Biologically, a nightmare or a bad dream is not a specific phenomenon. It is just a particularly vivid dream that can cause a strong emotional response of fear, sadness, or anxiety. Apart from psychological causes that dominate when people have recurrent nightmares, physical factors can also trigger or favor them. For example, sleeping in an uncomfortable position. Although this is not your case, since I told you at the beginning to adopt a comfortable position. Or having a fever can be a factor too. Even eating before going to sleep can influence dreams because it increases the body's metabolism and brain activity. Another proof that dreams are generated in the brain and cannot exist without a material substrate is the observation that people who have damage in the region of the brain called the parietal lobe typically stop dreaming. They may continue to live and sleep normally, including experiencing paradoxical sleep phases, but no dreams occur. A theory in neurobiology based on these types of observations is that dreams are a reaction to activities inside and outside the body. There can be changes in temperature, however imperceptible they are, and physical sensations. These signals reach the brain, where the active regions try to create meaning from them. This would result in dreaming, which in this case would be like an accident. Dreams would be a byproduct of brain activity, while the regions that would normally process these signals are inactive. Still, when we remember dreams, we can often recognize a lot of elements from them, taken from our lives, people, situations, places, emotions, fears, hopes. This is why the idea that dreams are important to the study and understanding of the human mind is as old as psychology as a science. Some of the earliest and broadest theories about dreams were developed in the late 19th century by Sigmund Freud. Initially, Freud supposed that the content of dreams was driven by unconscious wishes. In the architecture of the mind, he described, or theorized, that our conscious selves are just one layer. The unconscious mind would exist under it or behind it, and sometimes clash with the conscious mind or be exposed in certain situations when the conscious mind is asleep, like during hypnosis or dreams. There was a time in the 20th century when Freudian theories, which extended well beyond the interpretation of dreams, were quite popular in the scientific community and beyond. However, they have lost a lot of influence in the past few decades due to criticisms of his methods and modern experimental studies that tend to disprove his theories. One central problem with Freud's theories, and more broadly, the practice of psychoanalysis he started, is that they were never based on clinical studies on large samples of individuals. Freud elaborated his theories based on a small number of patients, and his followers did the same. When it comes to human sciences, we cannot create experiments where you control all the parameters as you can in physics or biology. However, there is still a scientific approach. You can prove phenomena by using statistics on large samples, be it in psychology or sociology. In history, a theory can be defended with documents and facts, concrete elements. When it comes to Freud's theories, there is nothing of this sort. They appear as an intellectual construction, using concepts that may or may not describe an aspect of reality. But in any case, they are invisible and impossible to measure. A way to know that they exist and can be acted upon would be to prove that these concepts can find applications in certain cures or practices and systematically produce effects. However, this was never done on a large enough scale to qualify as a scientific approach. This is one reason why Freud has fallen largely out of favor in the communities of psychologists and psychiatrists. His theories were somewhat at the intersection of science and literature, and they require that you accept his description of the mind without seeing any proof that it is anything more than an intellectual creation based on a few examples. But examples are anecdotes and not data. In fact, many psychoanalysts throughout the 20th century came up with different theories about dreams. To Carl Jung, a Swiss psychoanalyst, dreams were messages from the unconscious mind to help the dreamer resolve emotional problems. Another theory by Fritz Perls was that dreams are projections of parts of the dreamer's self that had been ignored, rejected, or suppressed. All of these theories offer different angles and are intellectually stimulating. But like Freud's theories, skeptics ask where the proofs are that these theories are anything more than the product of the author's imagination. Whether we choose to adopt or reject the theories of Freud and other psychoanalysts, maybe the value in their work is more in the invitation to look beyond the obvious when it comes to the human mind. They introduce the idea, which is now widely accepted, that our will and the way our minds work are not necessarily the same thing. We have hidden impulses, repressed memories, and emotions that are not rational, and that may come from places we ignore. All of this was a hidden continent before Freud and some of his predecessors in the 19th century. They opened a window on the complexity of the human mind and began looking for answers. So, in that sense, modern psychology and psychiatry owe at least a debt of gratitude to Freud. Speaking of psychology, psychologists are also interested in dreams, but most of the time with a different angle, a different approach. It is not so much about what dreams mean or reveal, but more about why we dream and to what necessity they correspond, if any. Here again, there are theories that are, in a sense, hard to prove, but they also offer a lot of food for thought. A first theory is that dreams are a useful tool to improve the mind's ability to meet human needs during wakefulness. This is based on the theory that we have mental patterns that help us solve problems and test what works and what doesn't in our awake life. Dreams would be a way for the mind to test new patterns to better our mind, in the sense that it will make it better adapted to survival and the satisfaction of our needs. To say the same differently, dreams would help select efficient mental structural outlines to eventually rewire our minds or solidify best practices. There is the underlying idea that dreams have a role to play in evolution. They would be an evolutionary feature that makes us better at surviving. Some psychologists have supposed that dreams evolved in our species and many others for threat simulation. Dreams would have evolved to replicate these threats and continually practice dealing with them. An element in favor of this approach is that, based on large samples of dream reports, people say that their dreams comprise many more threatening events than they meet in real life, and most of the time the dreamer engages with them either by escaping or facing them. So, according to this theory, dreams would allow for a rehearsal of threatening scenarios, perhaps about physical or emotional threats. They would help us anticipate and process them. Yet another theory is that dreams are mental gymnastics. They recombine elements in ways that would keep the processing of information in the brain flexible. They would breed creativity, and in that sense, they would help us thrive as individuals and as a species. But there are also numerous psychologists who concede that dreams are probably just a byproduct of physiology, like a residue of a system designed maybe to think and rest. There is a very broad research study on the content of dreams that took place at a university in Ohio from the 1940s to the 1980s. More than 50,000 dream reports were collected. From this wide sample, it appears that visuals and dreams typically mix different locations, people, and objects that the dreamer can recognize from their memories and experiences, blending into each other. Conversations often adopt a bizarre or exaggerated form. Another finding is that people who are blind from birth do not have visual dreams. The content of their dreams is related to other senses. Emotions are predominantly described as negative, with the most common one being anxiety. Positive emotions like happiness also appear. By definition, this is based on what people say and what they remember, so it is possible that negative emotions are more memorable. Sexual themes are present but secondary, representing no more than 10% of the content on average, and tend to decrease with age. Interestingly, a small minority declares that they only dream in black and white. This proportion was higher in previous generations, up to 25% for people who only were exposed to black and white film and television in their childhood. Long before understanding dreams through systematic studies or neurobiology, they had major cultural and religious impacts on human societies. Among those who left written records from ancient history are the Sumerians, the Assyrians, and Egyptians. There were variations in beliefs, but they generally considered dreams to be messages from the gods, like oracles. They announced events to come or showed the correct way to dreamers. In India and China, dreams were often seen as a journey of the soul out of the body during sleep. One aspect of the soul stayed in the material world, and another aspect was freed and could travel to the dream realm. Interestingly, in both of these civilizations, there was also questioning about the nature of dreams. In the first millennium BC, authors argued that dreams were simply an expression of inner desires, which is exactly the dominant approach that prevailed in the West in the 19th and 20th centuries, and remains very popular with the public nowadays. The ancient Greeks and Romans also had this dual approach. They were influenced by other cultures and initially believed that dreams were messages from the gods that visited the sleepers. In later centuries, though, several authors argued that the visions that occurred in dreams were produced by thoughts, conversations, or concerns that people had during the daytime. They also hypothesized that the producers of dreams were humans themselves. In Abrahamic religions, Judaism, Christianity, and Islam, there used to be a tradition that dreams were connected to the divine and provided messages or inspirations, and that bad dreams could be inspired by the devil or demons. There are frequent stories of dreams that provided divine inspiration in the Old Testament, for example. This emphasis on the meaning of dreams has faded away over time. In modern times, dreams are much less of concern. Early on, dreams were also a topic of interest for philosophers, and they made them question the nature of what we consider to be the real world. Some of them concluded that what we call the real world, or reality, could just be an illusion. We all know about this hypothesis. It is the basis for the idea that we live in a simulation, like in the Matrix movies, for example. But the Matrix is just a modern iteration of an old idea. Its first recorded mention is from the Chinese text from the first millennium BC. It was also discussed in Hinduism, and the idea was introduced to Western philosophy by Descartes in the 17th century. Dreams used to be seen in antiquity as neutral or positive because they could bring messages from the gods. But the Christian tradition evolved in the Middle Ages towards a more negative or harsher interpretation of dreams. They were increasingly seen as evil and inspired by the devil, which also passed to Protestantism at the beginning of the Reformation. This has to be put into context. In the late Middle Ages and the Renaissance, there were mounting concerns about the influence of evil or demons in the world, and they were actively tracked. This period saw the multiplication of witch hunts and the increasing influence of religious inquisitions. By default, unexplained phenomena or anything abnormal would be considered evil or strongly suspicious at least. In parallel to the religious traditions, there was also a literary motive or plot device that developed and evolved over the centuries, the dream world. Another world where the rules of reality are suspended and a character is placed in a marvelous and unpredictable environment. This is also an ancient device that appeared in antiquity. It was present in medieval tales and found wide popularity since the 19th century. When you think of Alice in Wonderland, Lovecraft, or The Never-Ending Story, there are plenty of examples in fantasy and other types of fiction in popular culture today. Dreams are almost always depicted as expressions of the dreamer's desires and fears. This remains very much inspired by the early theories of Freud. It is a bit unavoidable in fiction because you describe or show things only when they bring something to the story, when they matter. So when dreams appear, they have to be meaningful. They need to be some kind of message, some kind of prophecy, or they have to provide insight into a character. As we have seen throughout our story tonight, sleep is a different state of consciousness. In common language, we might say we are unconscious when we sleep. But it is not full unconsciousness because we can still react to stimuli and quickly wake up. There are states of much deeper unconsciousness, such as people who are in a coma, when they are unresponsive to external stimuli. Sleep is not that deep, which is why it is considered a state of altered consciousness. To conclude, I am going to tell you about two other states of consciousness related to sleep that are also on the consciousness spectrum: somnambulism, sleepwalking, and lucid dreaming. Sleepwalking is a phenomenon that sounds paradoxical. It is sleep and wakefulness at the same time. It always occurs during slow wave sleep. You remember in the various phases of the sleep cycle we talked about before, there is a state of quiescent sleep, not rapid eye movement sleep, during which we go through three different phases. This is the last, the deepest one, before we turn to paradoxical sleep with rapid eye movement. The cause of sleepwalking is unknown. There could be genetic predispositions, the effect of one or several neurotransmitters or hormones, but the truth is these are just hypotheses. No probable cause has ever been identified. For some reason, a sleeper suddenly begins performing activities that are usually performed during a state of full consciousness. Most of the time, these are just simple activities like walking or sitting up in bed. But in some cases, it can be more complex tasks like going to the bathroom, cleaning, or eating. Episodes have been recorded lasting from 30 seconds to 30 minutes. In rare cases, it can be dangerous because the person's perception of the environment and their judgment is impaired. There have been studies about the prevalence of sleepwalking. It is uncommon, but not extraordinary. 4 to 10% of people could have at least one episode in their lifetime. Another study has found that it is more common in children than adults. Another surprising state of consciousness is lucid dreaming, which is the name of a type of dream where dreamers become aware that they are dreaming, but the dream doesn't stop. This may give the dreamer some amount of control over the dream, putting them in a fragile or fleeting equilibrium because they can wake up at any time, but sometimes this state can last. The existence of lucid dreams has been documented long ago. Early Buddhists cultivated this awareness, and Greek philosophers talked about it. Scientific research about it started in the 20th century. It showed that lucid dreams could happen during REM sleep, maybe thanks to certain neurotransmitters that are present in higher quantities than usual. In this case, one called acetylcholine. Regions of the brain that are typically inactive when dreaming may be partially activated, allowing the sleeper to gain awareness that it is a dream. But this is by nature hard to investigate because it is all based on people's reports, and it is not an easy state to replicate with experiments. Other researchers have suggested that lucid dreaming may not be a state of sleep, but one of brief wakefulness, when people are on the edge between sleep and wakefulness. What they sincerely think is a dream could be a product of their imagination in this fleeting state at the beginning of awakening. A lot more could be said about sleep and dreams. As we have reached the end of our story tonight, it is now your turn to sleep. If you wish to, or if you don't, there are many more stories you can choose from my ever-growing library. And until we meet again, good night. Sleep well.